G'day everyone, welcome to Lubrication Experts. And today I've got something like super exciting. This is actually something that I've been working on for a couple of years, is to get three particular people into a virtual room. We've got Angie Cardis, Jim, returning guest, right? So I think this would actually be Jim's third or fourth potentially time on the podcast, and Mike Blumenfeld as well, someone that I've been wanting to get on the podcast for a really long time. So a little bit of background here. So Mike is actually the reason that this podcast exists. People might not realize this, but internally, when I was back at ExxonMobil during the dark COVID era, I tried doing an internal podcast called Mobil Ask the Expert, which was basically just an excuse for me and Mike to sit down and have a chat about technical stuff for fun. And I kind of enjoyed the experience. And so it became a thing that I did on the outside. So you have Mike to thank for all the listening hours. And then with what we really wanted to talk about today was kind of like wind turbine gear oils and their evolution. So obviously wind turbines play a huge role in today's power gen sector. And maybe something that's a bit underappreciated is the sheer amount of effort that goes into designing the lubrication systems and the lubricant themselves for the gearboxes. So they're kind of a special case. So, there's many gearboxes all around the world, but wind turbines get their own special gear oil, which is a little bit unusual. And we'll explore some of the reasons for that and the evolution of that here. Now, we effectively have here in the room three generations of wind turbine gear oil and, where they come from, right? So, and that's what I think is a great opportunity to explore here today. So, Angie, I might get you to sort of kick off with almost like the genesis, if you like, the genesis chapter of wind turbine
Yeah, I
gear
think
oils,
that's a
which in
good
the
idea.
which in the mobile world starts with now, the mobile naming convention always drove me up the wall, but mobile gear SHC XMP 320, which was obviously what ended up in almost half of the wind turbines worldwide. You were
Yes.
a leading part of the development of that. So would you mind explaining, what that product was for, and then maybe how did it end up in wind turbines?
Well, for us, a wind turbine is just one other application. But I came into formulating gear oils from developing additives for gear oils. One of our people retired and they asked me if I could move in and start working on gear oils. Um, Mobile Gear SHC XMP was a new multi-purpose gear oil. We already had Mobile Gear SHC, which is a heavy-duty gear oil, and we had Mobil SHC 600, which also was used in a lot of gear applications. But we were finding that there was something in the middle that didn't require this really hard anti-wear property. And the way we found it out was really kind of a disaster, because we found that if you have too much of this anti-wear EP additive, you can cause something called micropitting, which none of us knew anything about. Wasn't just in wind turbines, but that was like the worst case. So this new product was developed in conjunction with a European gear builder. We had an agreement that we would come up with candidates, and it was going to be ISO 150 to 680. We had 2 years to develop 5 candidates synthetic, 5 candidates mineral oil. And at the end of the 2 years, they would tell us which ones would be field trialed. So the field trials were wind turbines, but they were kind of small compared to what you're seeing today. But they were also things like we field trialed Mobile Gear SHC XMP in a coal crusher, because it was for all applications. In the United States, we were using SHC 600 for the wind turbines that we had in this country, and it wasn't meeting the application requirements for Europe. There are two different types of gearing involved. One is case carburized and ground, and the other is through hardened. The case carburized and ground allows you to put more power into a smaller unit, but they are also the ones that are more prone to develop micropitting failures. So we did our due diligence and we presented this builder with our candidates. And in the end, we had 2 mineral oil, 2 synthetic. And after the field trial, we had 1 mineral oil Mobil Gear XMP, which is still in use today, but not as much as Mobil Gear SHC XMP. The XMP in the name stood for extra micropitting protection in somebody's dream world. So you have, synthetic and mineral oil with extra micropitting protection. And when we first started out, we didn't even know how to test for micropitting. We got really fortunate because we had Martin Webster, who was working in our central research group. Martin was a tribologist, and he taught us what micropitting was and helped us to learn how to prevent it. So we field trialed in 1996. We released these new products in 1998, and they did pretty well. But as soon as you get into a wind turbine, you start seeing some of the problems that you didn't really anticipate, because just between when we started field trialing and when we commercialized, they were getting bigger. And while they were getting bigger in terms of power throughput, they weren't really getting bigger in terms of the charge of oil in these wind turbine gearboxes. So much more stress on the oil. We nevertheless continued on with the whole series, 150 to 680, but there were other things besides the gears that were a concern. And these different companies that developed seals and the different companies that developed interior coatings or exterior paint, they started developing tests that you had to pass to get their approval. And although we didn't have any problems in the field, there was one test that Mobil Gear SHC XMP was having trouble with, and that was believe it or not, a static seal test. And ultimately, we had to figure out why we were having a problem with a static seal, because eventually you're going to have to meet the requirement. So we did what we call donut and jelly, one of Jim's terms type of project, where we have the donut and we take one additive out and see what happens, and we take another additive out and see what happens, and then we substitute, and eventually we narrowed it down to what was the bad actor in this oil. So then we figured out the level of that bad actor and started looking at field trialing this. But when you take something out, something happens to the rest of a balanced formulation. So we had to make a few adjustments to the formulation before we could really commercialize this new oil. And that became Mobil SHC Gear. By then we had a high-level manager who wanted all of our synthetics to be named Mobil SHC something. And that was about the time at which I was ready for retirement. But besides developing the gear oils, I had also been heavily involved in the AGMA. We had had some interaction with AGMA in the past for different applications, but I hit it at just the right time when they were starting to develop the information sheet 921 for the lubrication, the design, the testing of wind turbine gearboxes. And see, we released the information sheet in 1997. That was before we had commercialized our product. But that was a really exciting venture because we had participation. We had some guys from Japan. We had a meeting at Aarhus, Denmark. We had people from Europe who came to the AGMA meetings, which back then they were multi-day meetings in like San Francisco or Chicago. So we pulled the whole world into what we were going to do with gear oils for wind turbines. And once that was released, we moved on to specification 6006. Now, the difference between a specification and an information sheet, the information said, this is what you should do. The specification says, this is what you must do. So you see, we took it one step at a time and further refined that. I think that was released in, I don't really remember the year. I think it was like 2003 or something like that. But again, we had this influence on the global market from the AGMA. So that then moved on to the ISO, IEC, and those other specifications. I actually retired in 2003, and yes, I'm still here.
Oh, that's awesome.
It's so much fun. They just can't get rid of me.
Yeah. So I think what's really cool is like at this part of the story, we've already touched on a few different things that I just want to pick up. Number one, you mentioned SHC 600, and I know that for a long time you were kind of responsible for that formulation. That particular formulation is kind of near and dear to my heart. So when I was a field
Actually, no,
engineer,
Jim was responsible for that at one time, but before that,
Jim is the 600 guy.
yeah,
Yeah.
yeah, that was almost my favorite product in the field because it just solved so many issues. But
it does
being
everything.
being a kind of the Swiss Army knife, you've identified a situation in which it doesn't quite stack up, right? So with the micropitting performance. The other thing is that most people think of SHC XMP as being only a 320 product because they've probably only seen
Yeah.
that viscosity grade out in the field because a lot of
I
people are
think they
unaware of the
still can
history,
get,
right? That
I
it's
think they can still get 460 because
It
they've used that.
depends. It, it's really a three at this point. It's really at the 320. I mean, like it is
Well, now
consolidated
we have other
around the wind market.
alternatives too.
Yeah.
Well, we have alternatives, and I did want to kind of gush a little bit on Mobil Gear SHC XMP 320 because, like Rafe mentioned, in the beginning, probably like 50% of turbines were on this product, and there was another formulation style which was metal containing, which was like the other 50%. And what we've ultimately seen happen is that the rest of the industry has consolidated around this ashless formulation, which was really Angie Cardis's baby of Mobil Gear SHC XMP 320. And if you look at the fingerprint, like the elemental fingerprint of all of the products that are out there today, I would say, 95% of them have almost identical fingerprint to Mobil Gear SHC XMP 320. And so it was way ahead of its time. And it was that initial seed idea that everything has kind of consolidated around.
Yeah, it's kind of like the top of the family tree,
Yeah, it really
for
is.
what
Yeah.
became all of the next generation
Yeah.
wind turbine gear oils, which is really, really cool. Maybe something to touch on as well, and this is one of the things that I find so fascinating about the lubricants industry. You mentioned XMP is for extra micropitting protection. So we've identified a particular mechanical failure mode, right, that is affecting gearboxes. Now, when most people think of micropitting, they think of it as being a fatigue failure. So this is, cyclic stresses that are occurring inside of the gears. You get crack propagation, eventually you get the formation of pits. So I think what everyone is fascinated by is, well, how can you use chemistry to address what is fundamentally a mechanical issue? So what is kind of like the magic dust without going into anything proprietary, but how is it that you can use chemistry to fix what is fundamentally a mechanical problem?
No,
You need a test method first too. Go ahead, Jim.
You're you're going to get 3 different answers from this one. You're going to get 3 different perspectives. So I think, yeah, Jim, go for it. Let's see what your perspective is.
Oh, you bouncing the ball to me?
You got it.
Well, as you can probably tell, Angie's an organic chemist. I'm an organic chemist. And Mike, would you consider yourself a physical organic chemist?
I'm a physical chemist.
Yeah. Well, I'm a wicked hardcore, as they say in Boston, molecular designer. So that's how I come into the industry. So if it's made of carbon, I can make it. If you can draw a valid structure on a piece of paper, I can design it for you. So that's actually how I got into formulating lubes and whatnot. Just like Angie, I started with Mobil many years ago, Heritage Mobil, in the additive and base stock design group that Angie was also in. Of course,
Jim, you actually started at Temple University many more years ago as an undergraduate chemistry major when I was in a PhD program and I was your teaching assistant.
Oh, wow.
So we go way back. We're old Philadelphia stock.
Yeah. You cut me, I bleed green. We're Eagle fans, right? So, yeah, back in the 1970s, the Jurassic era. That's when I was an undergrad.
I was being born in 79.
Oh, that's the year. That's the mint year of my bachelor's degree, 1979.
Yeah.
So that's how I got into this. I actually started off my educational experience as a mechanical engineer, and just on a whim, I was following a girl on the first day of class to organic chemistry, and I sat down with her, and I was like, "Holy smokes, you can design molecules the way you can design a bridge." And that was it. If I just pick up a thread on what Angie was saying, the go-to solution, Rafe, for you was always the Mobil SHC 600 series, and that's a product near and dear to my heart. When I first came into industrial lubes back in the late 1990s, right, there was a lot of things going on at the same time. When it's a shame we don't have a timeline up on one of these slides, because the wind industry was both expanding in its volume of machines, but it was also expanding in terms of the load and carrying capacity and generating capacity of each machine exponentially. So you've got these gearboxes that were probably a quarter of a megawatt, would you say, Angie? Maybe in the mid 1990s?
Yeah, field trialed in something like that. Yeah.
Yeah, actually, you could, it took until about the year 2000 or 2001 before the wind industry sort of standardized on what's called the Danish design, which is the white bus on a pole with 3 blades. Before then, you've got all kinds of Wild West designs, 2 blades, open skeletons, stacks, all kinds of different things, even horizontal, as opposed to vertical types of.
I remember that too.
Yeah, and eventually, the thing about mechanical design is kind of like accelerated Darwinism, right? Eventually, all fish look like fish over a few billion years, and all wind turbines eventually start looking like wind turbines over about a decade, and that's kind of what was happening right around the time that Angie was thinking about retiring. And just like Mike and Angie were saying, that the Mobil Gear SHC XMP was purposely evolved from the metal-free, VI improver-free, sulfur, well, not sulfur-free, but really just sort of the very controlled heterocyclic and non-metallic additive systems that came out of the SHC 600 formulating philosophy. And then, I think when Angie retired, simultaneously to having an explosive volume of material going out the door and applications, there was a big push within Mobil, or ExxonMobil at the time, to actually improve on the performance of Mobil Gear SHC XMP, and that's how that product development came into my portfolio, and that became the genesis of the SHCWT series. SHC 320 WT. And I apologize for the burdensome nomenclature system there. I tried to call it, nobody listened to me. I tried to get it to be called Wind Turbine 1, which I thought was short, elegant, and easy to understand. But I also
No one
tried
ever
to,
listens to you, Jim. As soon as you said that, they said no. Doesn't matter if it's a good idea.
I actually tried to dye it blue, and I got a lot of grief about that too. So,
Yeah, I remember that.
oh yeah, you dyed it blue, Jimmy. Why'd you make it blue? Well, didn't tell me. No.
So maybe as we start to get into the sort of this next evolution, right? So we've got SHC XMP. It was primarily designed, let's say for example, for industrial gearboxes. It's found a home in wind turbine because it's able to solve this very specific issue, and we will get back to the micropitting thing.
Mm-hmm.
So we've got this evolution. But then, as you said, the wind industry is also evolving at the same time, right? So it's almost like, the formulations are having to play catch up with evolutions in wind turbine. Jim, you've already said, hey, everyone is starting to coalesce around sort of like the Danish model of wind turbines. So the designs themselves have kind of standardized. And my impression from knowing a very little amount about the wind industry is that from this point onwards, it's basically how do you make them effectively larger and more efficient, right? And put more
Yep.
power, more torque through the gearbox. So how does that then, affect that next generation of wind turbine gear oil? So now we're starting to move from the SHC XMP era through to the SHC gear 320 WT era.
Yeah. Okay. Yeah. So, yeah, I guess it bears keeping in mind that whenever you introduce a product without any updates, it's timestamped. It's like any idea or patent that you write, right? So when Angie introduced the Mobil SHC XMP, it was the top performing lube for the wind industry for the machines at the time in 1997, 1998, when it first was commercialized. And within 5 or 6 years, it was already, there were already complaints about different little failures here and there, or we've got to keep things moving just for the reasons that Rafe was saying. If you start off with a quarter of a megawatt, yeah, all of a sudden you go into a megawatt machine and then a 2 megawatt machine. And like today is standard of 2.5 megawatts or bigger. Mike and I, before I retired, we visited Samsung and they had a 9 megawatt machine. And now that's even considered to be surpassed by 11 and 12 megawatt machines. So it just keeps getting bigger. It's probably a testament to the Danish standard design, which is scalable. So you don't necessarily have to be locked into a single megawatt. You can multiply it by 10 or 12, make it larger and larger. And, as a consequence of that sizing problem, or the sizing problem, the one thing to understand is that there's so much power going through, particularly at the input pinion of the very beginning of the wind turbine machine. It's only spinning at about 9, 10, maybe 11 RPM. So that input pinion is putting pressure on a dual planetary set. So one of the things you got to realize is that at least half power and as much as full power throughput in these machines, the gears bend every time they engage with every cycle. Millions of times an hour, billions of times a week, trillions of times a year. So you've got this bending and flexing of the gear teeth that you absolutely do not see in the automotive sector. You don't see that in a lot of standard industrial gear sets. And I think as Rafe was saying, the designers of these machines, bigger, not faster, but bigger, more powerful, bigger and powerful. The more power throughput these machines see, the more stresses that these gear teeth are undergoing. And SHC XMP was a great lube for 5, 6, 7, 8 years. It still is a great lube today for lightly, not lightly, but more typical loads. But when you get into these much more heavily loaded machines, there's a big push to actually take everything that Angie had done with micropitting and bearing wear and scuffing, and take all those things that were on a scale of 1 to 10, between 8, 9, 9.5, and just peg everything to performance criteria maximum. And that's really where the SHCWT came in. My job was to take a great micropitting oil and make it the best, bar none. And it took us a few years to do that, while keeping an eye on scuffing performance and bearing performance. So when we finally got to the final stretch of improving things, just like Angie says, there was a lot of stress on a lot of extra stresses on the development project to maximize performance in seals, hoses, all the secondary performance criteria, not the primary mechanical performance criteria. And just like we had mentioned a little bit earlier, a few people, I think everybody had mentioned, is coming up with a valid screening tool. Luckily in Paulsboro, we had two, thanks to Angie, I guess we had two full-scale FCG micropitting test rigs where we could actually take these tests that run at the FCG Institute or some of these other German universities for qualifications, and actually run those machines and those gears in Paulsboro, so we could actually come up with a test. But one of the key things on top of that wasn't just being able to run a test that's being run in Germany in Paulsboro. The throughput for each machine was only 4 data points per year if you ran it exactly the way the German institutes do it. But we figured out a way, working with the FCG Institute, to actually run 1 data point a week. So that was really the secret to success, is to be able to run over 150 micropitting tests within a 2-year period in Paulsboro. So the key thing there was not just finding what worked well, but also discovering what didn't work. And we basically ran the gamut, being what I think is a good organic chemist. I had a sample of everybody else's product that were in the wind industry at the time. So I knew exactly what my targets were. And just like working in a garage, rebuilding your own engine, you just, first thing you got to remember is don't put your fingers in the vise when you're trying to fix something, So I stayed away from metallic additives. I stayed away from sulfur. I stayed away from a lot of. That's really kind of the big piece there. And one of the things I wouldn't say stumbled into, but one of the models in my mind about developing the highest performing gear oil that you could attain was that micropitting is actually controlling micropitting in the chemical sense. To get to your point, Rafe, about what are you doing with the chemistry, it wasn't just a question of anti-wear. We were looking for additives and base stock systems that would mitigate denting, because I believe that the beginning of micropitting is actually the denting phenomena of the torque bearing tooth into the root of the torque receiving tooth. So if you can mitigate that initial contact of the tip against the base, or I guess that's the dedendum of the receiving the gear for the torque, and just somehow figure out how to keep that from being so abrupt and violent in the microscopic sense. That was really the key to it. So it wasn't just the additive systems. Along the way, we actually discovered that this extreme modal blending methodology did a great job at mitigating these dent phenomena and mitigating micropitting. So I could actually see a tremendous benefit in micropitting with virtually no additives in the lubricant at all. It didn't solve all the problems, but it significantly improved things. And that's really the genesis of the metallocene PAO that we were talking about. Because with conventional PAO, you kind of run out of low temperature performance. You run out of microscopic tribological phenomena, and with the metallocene blends with very low viscosity hydrocarbons. So instead of typically what you would do to get to ISO 320, you would take PaO 100 with a little bit of PaO 40, and then a co-base for your additives, and that's your formulation. But with the extreme modal blending, we separated the viscosity of the blending components as far as we could, and we saw tremendous benefits in wear protection just by blending the hydrocarbons correctly. And that's where people like Margaret Wu came in, and she helped us with the chemical company develop the metallocene PaO series. We started off with the 150 centistoke material, and that progressed into 300 centistoke and beyond. So we had a lot of success, moving technology forward within the wind turbine gear oils, but it actually spread to other things. It really improved the performance of SHC 600, for example, and all the other Mobil SHC product lines as well.
So maybe I just jump in here. So
it's
Mike,
hard.
you mentioned that there might be 3 different answers to that question. So
yeah, absolutely. You're going to get a different story. I mean, one of the reasons we worked so well together is we've all got different approaches of how we hit a problem. And so I can give you my answer as to, so the brilliance of Angie's solution for micropitting, which she did with Martin Webster. So it's like a skyscraper, right? If a skyscraper is falling down, you think, oh, I got to make it harder. I got to make it sturdier. I got to make it stiffer. I've got to reinforce it. And then, the next earthquake comes, the next, big windstorm comes, and it falls down. What Angie did is she actually made it softer. She dialed back that anti-wear to an extent where it was no longer kind of locking in asperities. It wasn't hardening the surface to an extent where you could actually form micropitting. It was allowing the gears to run in. It was allowing that initial smoothing of the surface so that and this is different. Like everybody else was saying, no, go more aggressive anti-wear, reinforce it. Angie dialed it back. And because of that, you would lose the asperities, it would run in correctly, and you would not form micropitting. And so that was really that's that counterintuitive piece where balancing that scuffing protection, which does require some surface reinforcement, and the micropitting protection, that's the hard part, is getting them both to work at the same time.
yeah, that's really interesting because I've heard often that scuffing and micropitting performance often run against each other, and that's part of finding when
Yes,
everyone
that's
talks
true.
about balancing a formulation is how do you basically address both concerns at the same time. I've never heard it expressed like that.
But what Angie was doing, but I mean, what's crazy is you have to go put yourself in that mindset. Like when Angie was doing it, like they were looking at this gray staining stuff, trying to figure out what it was. Like, why is it like flaking away on the surface? And so it's kind of, you're right. At this point, it kind of feels almost like second nature. Like, oh, this is the textbook definition. There was no textbook at the time, which is the which I find very inspiring, that you can figure something like that out from just doing the experiments and trial and error.
And Martin was essential to this because he had worked for some helicopter outfit in the UK where you have, again, really serious need to have safety factors built in. So he had some techniques. I mean, he was slicing through things and looking at them under microscopes and taking pictures of them. There's some really neat pictures that Martin was able to provide us with, so we could actually feel what was happening.
Yeah, that's really interesting. And I guess for anyone who's in the industry, I mean, Martin Webster, if you are kind of remembering that name, I guess it's most people would have seen his textbook, right? Which is Martin and Don Pirro, who put the Lubrication Fundamentals textbook together. That's probably where you've come across that name before, even if you're not in the even if you're not in the mobile world. It's always really cool to hear.
He was also in the organizations that are important to the lubrication industry. He was recognized there again because of his tribology background and strong publications that he put out and things like that.
Past president of STLE. He was an STLE past president. Yeah.
So Angie, that's actually really kind of a good segue into something that I wanted to talk about. So in the timeline, we are now at sort of like SHC gear 320 WT, right?
Mhm.
And one thing that we talked about was the way that the designs for the wind turbines have coalesced around the Danish design, and now it's a process of just getting bigger and getting larger. Now, when you get standardization, generally what happens is you also get standardization of like the testing criteria that go along with a particular industry, right? And you mentioned that one of the challenges at the very beginning, as you were designing Mobil SHC XMP, was that there wasn't really any standardization among the tests. So we're kind of you're sort of shooting in the dark a little bit. So maybe as these tests begin to standardize and sort of harmonize, um, you mentioned that you were involved in AGMA.
Yes.
So to what extent, I think this is sort of like interesting to see how industry and industry bodies and the lubricant companies kind of all come together. Where is everything being driven, right? So who is standardizing that test slate? Is it predominantly driven by the OEMs?
I think it's the OEMs, but there's something
Yeah.
also that AGMA did that I think is very important. And there was a lot of pushback, but they had the philosophy, if you're working to provide a lubricant to a gearbox, the best test is with a gear. So they dropped like the Timken OK load test and the four-ball wear
ball.
test and the
Yep.
four-ball EP test, because it's not indicative of anything real. And there was a lot of pushback because that test was in the industry for a long time. Funny thing is that the people at Timken, they didn't like the Timken test, and they were happy to see it go away because they recognized that it wasn't realistic.
Mm,
Like, where do you have unidirectional sliding?
yeah,
I was literally talking through that with an OEM this morning and going through why
See,
the
they
FCG
don't want to
scuffing
give it
test
up.
is better than the four-ball weld or the four-ball wear test.
Yeah, they don't want to give it up.
yeah,
It's easy.
yeah. No, that definitely. Okay, so that's really interesting.
But
So
as
that kind of
far as specification tests are concerned, the micropitting test, the FVA 54 test that was developed at the FCG Institute, I don't even know if today, Mike, is it an official test method now?
It's in the DIN.
Because
Yeah, it's a DIN method now.
it isn't, does it
It
have a
is a DIN
number?
method. Yes, it does. I can't remember it off the top of my head.
And it probably stops at 12? Do you see that?
Wait for the for the
No, wait,
micropitting test.
10,
Stops at
10,
10.
10. Micropitting's
10.
10,
Yeah,
yeah, yeah.
yeah.
yeah. Oh, fascinating. Okay, so again in the timeline. So what's happened is we had Mobil SHC XMP
Hmm.
developed as an industrial gear oil, kind of found a home in wind turbine because of its really good micropitting performance.
Yeah.
Then we kind of evolved, and Jim sort of took that formulation and let's say expands the performance envelope. So, better micropitting performance, longer life, better foaming performance as well, things like that. And what you saw was, well, at least in my experience, was also extension of the drains as well. So where it was pretty typical originally, maybe you were doing a 5-year drain, they started to get pushed out to 7, 8, 9, sort of 10 years.
Yeah.
So that now brings us almost into the present day, which is what is the kind of the next generation of wind turbine gear oils, which is Mike's baby. So now we're talking about the new wind power product, right?
Yeah.
So how do you take something that was already performing really well, and what are kind of like the drivers from the wind industry side that are requiring a next generation product?
So I would say the biggest realization is just how cost competitive the wind industry is, right? And so, we started with something that was, that was working. We optimized it for like the low temperature properties with Jim and the micropitting properties. And then we had to recognize that, okay, the wind industry is getting more mature, and everything that we bring to the table has to provide a return on investment for the customer. So it's no longer good enough just to be sexy. It's got to be, it's got to improve the bottom line. It's got to make sure that that is providing that return on investment. And so we looked at what were folks appreciating the most about Mobil SHC Gear 320 WT. We now had this product that we could take, and we could say, like, well, which of these features are you really excited about? And the things that came back were how compatible it was with plain bearings. So the fact that it was compatible with just about everything, all of the exotic materials that go into plain bearings, the oil drain extension, so that, when that product was released, it had a 7-year warranty, and then we took it to a 10-year warranty. And what we found is that, like, customers were hungry for more of that, right? Because every time you can prevent the trip up tower, you're saving a lot of money from not shutting down the turbine. You're not wasting the oil, and you just get a lot of peace of mind of just knowing that your investment's taken care of itself. And so we really kind of focused on that, as well as trying to figure out, well, how do we extend even further, and what kind of tools can we bring to the table to make sure that that folks are getting the most out of their investment in the product. And as Jim mentioned, the metallocene PAO. So one of the learnings from Mobil SHC Gear 320 WT was that the PAO was much more durable than we gave it credit for initially. So what we had a lot of used oil data from SHC XMP, from WT, and we found is that the base stocks weren't degrading. What was happening was the additives were depleting. So we came up with a bunch of schemes for how we can address that additive depletion, either in situ or from the beginning, and make sure that we were maximizing the lifetime, and that everything would kind of age at the same rate. So that was those were kind of the North Star mindset that we came into wind power with.
Yeah, awesome. And now wind power is kind of also designed around like fill for life philosophy, right? So now, I mean, what typical gearbox life is around 20 years, give or take.
Probably longer, probably 25 years, like these days. But yes, give or take. And they're getting longer, right? I mean, they've managed to really improve the longevity of the gearbox itself, which is, provided the need for that longer life gear oil.
Yeah, and I guess to your point about oil drains and that kind of thing, changing oil on a gearbox that's that far up tower is not a trivial exercise. It's not like in a mining application where you can just walk out to the gearbox and drain off 20 liters and fill up with 20 liters. It's a very involved exercise, particularly if you're offshore, right? Because then it's a whole kerfuffle. And so minimizing the number of oil changes that need to be done over the life of the gearbox is like a big deal for wind, especially if you've got a wind farm which might be 100 plus turbines or something like that, right?
Yeah.
So with the wind power product, like, what are the differences from the previous generation that you found kind of move the needle?
Right. So there's a higher initial additive treat in wind power that provides that ability to kind of go the extra mile in that first warranty period. But it's also the ability to accept top treats. So we've actually designed it with top treats in mind and with condition monitoring in mind, such that it plays well with online condition monitors. It plays well with online particle counters. It plays well with the top treats, and is able to accept these in a way. And the way Jim would put it is, the philosophy has been to work in tandem with the filters, right? So we don't want the oil to be holding material and degraded additives and sludge and varnish precursors and things like that. We want it to work in tandem with that filter, because often the filter is getting changed far more frequently than the oil, or it should be. And so you want the oil to work with the filter to get rid of any of the degraded additives that are in there, make sure that the oil is staying clean, make sure that it's only holding what it's intended to hold, and everything else is getting flushed out with the filter, just like the kidneys work in the human body. So it's really treating the system holistically and looking at it from the operator's view and saying like, okay, how are we going to make this operator's life easier? Because ultimately, at the end of the day, it comes down to how do we lower the cost of energy coming out of the turbine? That is what the operators want.
Yeah, that's really interesting. So now, I mean, this is something that we've often found, in general industry, right? When you're changing over from minerals to synthetics, one of the issues is contamination control, right? So, you spend all of this money on a fancy new synthetic, gear oil that's going to last 3 times longer than the mineral. But if people dump a whole bunch of alumina dust into it, then it kind of defeats the purpose, right? So now contamination control becomes a much bigger deal. So it's interesting to hear that you're sort of working with the filtration system.
Right.
Now, in terms of like the condition monitoring side of things, right? Wind turbines are a great kind of use case for real-time oil analysis because taking samples is also not a trivial exercise, and I tend to find that it's like the bane of everyone's existence on the service contract side when they have to go up tower and take samples. So, what are the kinds of things that if you were an operator, what are the signals that you are looking for in your oil analysis? Because it's a combination of you want to, hopefully get early warning signs of any kind of wear. You might be interested in contaminants if they're in there, because that's fundamentally how kind of like the oil's failing. But you might also want to get a sense for, if there are top treats involved, can you get a sense for when the top treats need to be done?
You can. And that's, I think, going to be part of the fun of the next, 5 years, 10 years, is optimizing those top treat intervals, because it's not clear that there is one specific way. The entire system is designed to be kind of flexible so that, it's very difficult to overtreat and do any damage. But one of the things that Jim did with WT, and I was able to take advantage of, is he's designed into it, probably without knowing, he designed in a phosphorus fuse into the system that there are quite a few phosphorus sources in Mobil SHC Gear 320 WT. And because of that, you can get a very good sense of the kinetics as to where you are in that, in the lifetime of the product. You have the fast acting, you have medium acting, and you have your long acting. And so by looking at where you are on that curve of the phosphorus, you can actually determine when it's time to re-additize. And we've also optimized the additization. It's not just the add pack of the product. It's not the exact same thing it was to start off with. You actually need to make sure that you are enriched in that fast acting material, and you don't need as much as the slow acting material, but that gives you that best balance and allows you to maintain that balance straight through the life of the product.
Yeah, well, that's well said, I think, because it's one of these things where, in the design of the WT formulation, we were looking at 5 and 7 year drain intervals, but we never really encompassed or need to encompass the longer drain intervals, 10 years and longer. And if you think about it from just a fundamental basis, that's the additives are designed to wear out. Why wouldn't they? Why would you expect the phosphorus level 10 years into a service life of a lube to be, within 10% of when it started? No, I would expect it to be mostly depleted. So, it's not rocket science. Anyway, so sorry for interjecting there.
No,
that's great.
No, it's perfect. And that's one of the fun things about this project is, I was able to use Angie's test to determine the life. I was able to use Jim's, multi-phosphorus scheme to kind of set that fuse. So, it really does feel like we've been working like as a team across, 3 generations, 3 decades of just activity to get to the point where we are today. It's exciting.
Yeah, that's so cool, and that's one of the reasons that I've been angling for this podcast for a long time, is to get the 3 of you kind of in this room so we could see that like direct line of evolution, And I think the key is it's not just evolution of the product, right? It's also evolution around thinking about the product as a system, right? As it goes into the wind turbine, how you're addressing different failure modes, how you are kind of overcoming challenges within the formulation. I just find this just fascinating. Maybe as we start to wrap up these podcasts, I always like to get a bit of a window into the future. So it's crystal ball time, right? So we've touched a little bit on what the future looks like in the immediate future, right? So the next 5 years, you've talked about, Mike just talked about like developing the sensor technology, developing, the additive top treats, which I should say is kind of new thinking, right, in our industry.
Yeah.
Traditionally, we've shied away from additive top treats,
right?
And so there's a bit of kind of an education piece that has to go along with that as well. Maybe Angie, you've got, let's say, the longest runway into today. So
Yes.
if you had to get your crystal ball out and say what do wind turbine gear oils and what does the wind industry look like, 10 years and beyond, right?
Well,
Where do you think
one
there are going to
thing
be some interesting changes?
that I was thinking about when I was thinking about this program, I can remember back in the 1997s, 98, that late 1990s, going to California, going to different OEM sites out there, and it was obvious, and actually it was told to us that when they get their money from the government, they manufacture and sell wind turbines. If they're not getting subsidies from the government, that's when they bring in the ones from the field that have problems and they repair them. So it's kind of like alternating. I don't know if they still do it that way or not, but I think that the industry needs to find a way to be, I think, self-sustaining and not need infusion of money from the government if it's going to continue to expand. And I really hope it does, because I like seeing them. I get upset when I hear somebody say, "Oh, these things are ugly." No, they're magnificent.
Yeah.
Just flying into Copenhagen, and they got this line of wind turbines along the edge of the water there. I just found it thrilling. A little weird, I know, but it's exciting.
I love it.
Jim?
Yeah, I mean, just to pick up on the thread that Angie's talking about, I mean, the support for wind in our government is, it fluctuates with every election cycle, right? So it's an unfortunate reality. But the very, very few politicians have the long view, which is 10, 15, 20 years out, or even 100 years out, which is, I mean, who knows when the crude oil and hydrocarbons are going to start to run really short. I mean, you see a microcosm of that, like Angie's talking about in Denmark. I mean, they have no hydrocarbons whatsoever. There's not a single well that I can think of in Denmark. And, so they get 60-70% of their electrical energy from renewables, whether it's wind or solar. So you see places like that, even a place like Turkey. Turkey has very, very few hydrocarbon resources, and they rely a lot on renewables. So it isn't until you start to recognize that, burning hydrocarbons for fuel purposes and electrical energy generations is kind of a waste of a raw material. I mean, as a chemist, I'd rather save it for other applications, fine chemicals, pharmaceutical feedstocks. 80% of all pharmaceutical feedstocks come from crude oil. In terms of future proofing civilization, you really want to try to save crude oil for the future. And that's really where I think the wind industry and solar in general, and any kind of renewables, is going to go and play an important role. In terms of two things that I want to add to where things are going to go in the future, there's this back and forth between who's responsible for the failures in the field currently. Is it bearings or is it gears? And I think we've pretty much settled the gear question, and we've solved the gear problem, but we still have bearing issues. So things like white etching cracking is still WEC is still an ongoing problem. And one of the things that came out of our research with the SHC WT is that I'd rather be lucky than good, in that metal containing additives are absolutely horrible. They propagate white etching cracking, and they're responsible for way more damage than you would normally think is responsible there. So bearing technology's got to get a little bit better. The design of bearings has probably got to get more clever. Sizing of bearings relative to the power throughput. So that's probably going to happen. I see that continuous improvement for, as you were talking earlier, Rafe, chemistry versus machine performance. It's one of the things that fascinates me as a chemist, a professional chemist, is how chemistry is integral to everything. So machine technology, as it gets more and more evolved into the future, is really going to lean more and more on folks that have that sort of schizophrenic mind, half machine man and half chemist, sort of playing with each other in the same brain. So I see the industry moving more towards what I would consider, you try to look for someone who's got a background in chemistry and machine design, and they just don't exist academically. You might point your finger at something like tribology, but that's not the case. You need someone who has two legs in two different magisteria, one in the science and one in the engineering. And it's very difficult to find people like that to seed the future for the industry. So that's my 2 cents.
Mike, it looks like we've got jobs secure for the next little while.
Yeah, I know. Well, let's hope so.
And in some ways, I kind of actually wanted to have a little postscript to this discussion, right? Which is that, aside from what Jim just mentioned then, we didn't talk about white etch cracking at all.
I know, right?
Right?
I was thinking that too. I was like, I can't believe it hasn't come up yet.
Yeah. So maybe, Mike, just in this little kind of postscript to the interview, do you want to just maybe briefly talk about what white etch cracking is for the uninitiated, for anyone in the wind industry who somehow hasn't heard about this phenomenon yet, right? How it differs from something like a micropitting failure, right? Some of the work that you guys did, let's say, for example, the heavy water experiments, to show the sources of white etch cracking, and then what are we doing formulation-wise to help kind of prevent what is become, a pretty commonplace failure mode?
Oh, that's a lot to talk about in a postscript, but I can try. So white etch cracking, axial cracking is how, again, like if you're a bearing guy or a bearing woman in the wind industry, you're going to be looking at what happens, right? The bearing literally like shears itself in half. And seemingly without warning, a lot of times it's completely unpredicted. Like none of the normal, bathtub curves or Weibull analysis predict this is going to happen. Big confusion in the industry. Like, where is this coming from? Why is this happening? It looks like there's a lot of different potential contributors. It looks a lot like hydrogen embrittlement, which is kind of a more traditional failure mode we see in steels and in various industries. But what Jim was able to do with some of our colleagues, Tabasimo Hawk, Peter Jacobs, they were able to really identify what were the chemicals that were in the lubricant that were contributing to this hydrogen embrittlement, white etch cracking failure. They were able to do it in the lab. They worked with collaborators at FAG Scheffler at the time, and they nailed it out of the park. They had some great data, and I think now we're getting to the point where it's accepted science that in particular zinc containing additives are just not okay in a wind turbine gear oil. They strongly influence the formation of white etch cracks. And we've been able to show that in the ashless formulations that, Angie and Jim put together, that white etch cracking, that the lubricant related causes are effectively eliminated. So that was some really great work. They were able to show that, that deuterium so they basically used heavy water, they put it into the oil. They were able to show that heavy water actually made its way into the steel. And then when they took the steel out of the experiment and they put it in a vacuum chamber, they could see the deuterated hydrogen coming off of the system. So, proving that it was actually getting incorporated into that steel. So really exciting work. And we've incorporated the learnings into wind power. And I think that, it's generally accepted. We've seen a lot of follow-up work. We've seen some great work from Argonne National Labs, who's continuing with some work in electrification, as well as University of Southampton University is also doing work on electrification, electrified contacts, and white edge crack formation. So still an area of research, but we've come a long way in the last 10 years.
Yeah, and probably I guess one of the keys from the wind power side of things, right? I think SHC Gear kind of carried this as well. You went through the process with DNV, right? Of actually getting it sort of certified that it doesn't contribute. What was the exact wording on it?
It's basic. It doesn't contribute to the lubricant related causes of white etch cracks. So it's basically like asking for an audit, which is not something I would normally do. Jim and I are usually the two people who they will send home on audit day because they don't want us speaking to the auditor. And so I remember like him and I being locked in a closet saying, "You guys go meet in here while we have the audit over there." But no, we invited the auditors from DNV in. They combed through all our records, looked at all our papers, looked at our equipment, made sure that everything was calibrated, certified, and they put their stamp on it, which was that was an honor in and of itself. Just seeing that, like we went through the ringer with that one.
Yeah. And just to sort of put a little bow on it. So with this next generation product, right? So with wind power, so I guess WT versus WP is going to get.
I know. We knew that was going to happen. We knew that was going to happen.
So it's actually two different products, right? So you've got the actual lubricant itself, and there's the top up is called
Extra.
Extra.
Extra, Mobil Extra. It's basically like the family of top treats, because again, we kind of thought through what are the different failure modes that can happen for a wind turbine gear oil. How do we make sure that none of that, that we're not taking a charge of lubricant out before it needs to be brought out of the system. The mindset was we want to give the operators control over their O&M. Do they want to do an oil change, or do they want to try and treat the problem? And if they want to try and treat the problem, we're going to be there with them with whether it's adding additional defoament, whether it's re-additizing holistically, whether it's in particular yellow metal passivator that needs replenishment, if they're having issues with copper, if they're having viscosity drop due to contamination or due to shear, then there's something available for them. They don't have to feel alone.
Right. Okay. So that's a pretty important point that maybe we didn't highlight before, is that the Extra series is actually a family of different top treat additives, right? So depending on how the oil is failing is not the correct word, but basically which additives are starting to deplete, we can then address each of those in turn to get the maximum life out of the actual gear oil itself. And once you go through that process, so there's a bit of hand-holding that is going to happen with the customer base. But once
we need lube engineers. Yeah, we need lube engineers out in the field.
Yeah. Once you I'll put my phone number. Once you go through that process, I mean, are we looking at kind of like 20 to 25 year oil life to match basically the gearbox life?
We're looking for 25-year oil life. So that is that is the expectation based on the work we've done internally. And that's one of the DNV certifications we got for the white edge crack work. We also did it for the fill for life potential. And that really is around the Mobil Extra EP, which is that full additive replenishment system. For things like the anti-foam, that's something that we've just recognized over the years, that customers sometimes want the ability to solve a foam related issue on their own, to work through it. We're not expecting any foam related issues, but knowing that it's there sometimes is just peace of mind enough to say that if it happens, we've got a fix for you.
Yeah, and
we're not expecting to sell a lot of it.
Yeah, and one of those things as well is like, if you do encounter a foam issue, to maybe get a hold of your local Mobil rep, because I have seen any number of people try to solve foam issues in the field on their own, and it has always ended in disaster.
Honestly, the concept of oil as an asset, we cannot take credit for that. This was a really very important person to the wind industry, from Vattenfall, who really coined that oil as an asset, and he was the one who educated us on the potential for lubricant, and not to think of it as something that is disposable or something that is a consumable. It's a part of the engineering. It should be treated as such. You don't throw it away, you fix it.
Yeah. Hey, and I think that's a really, really good place to end. I mean, the way that the OEMs are starting to evolve their thinking around lubricants as well has been really interesting. And that's not just in the wind industry either. I've seen on the engine side, even for large industrial engines, that people are starting to view the lubricant in the similar way to the way that they would design a bearing, or that they would design, a piston ring. It's just become another component, within the system, that they also need to kind of design along with the oil companies. Now, Angie, Jim, Mike, thanks so much for taking the time to talk through all things wind turbine gear oils. This is something that I wanted to put together for a really long time because of your association, not only just on the wind turbine side, but also on the SHC 600 side, which is, like I say, it's probably the nerdiest thing ever to say that you have a favorite lubricant, but that one is mine. Got me out of a few sticky problems in the past. And so, to have, these, 3 generations together to be able to, talk about the evolution, not only of the product, but the thinking around the product and the way that the industry has evolved its thinking as well. And the influence that you guys have had on the industry has been really, really awesome. So, no, thank you so much for your time.
It was fun.
Thank you, Rafe.
Yeah, let's do it again.
Oh, it was a lot of fun.